Okay, so hello everybody. We are Jérôme, Chapelle and Hervé Toureille. We are both engineers in charge of the data-centric architecture at CINES. So we are here to present you a feedback about our data-centric architecture. But first, I'm going to present you the CINES. Then Jérôme will talk about the data-centric architecture. Then we talk about our current architecture with a lot of Lustre-HSM inside. Then a small demo on what we can do with the Lustre-HSM system, and then our conclusion. So, CINES is a National Computer Center of French higher education. We are a French public organization that provides some computing resources and services to the French public research. We are located in Montpellier. We are about 55 persons, most of technicians and engineers. So we have three missions. First is HPC. We are hosting and administrating two supercomputers. One named Yoda is from, it's a Power 7 computer from IBM, but it's going to be stopped at the end of the month. It's a 2.2 teraflop system. And we have a brand new supercomputer made by Buell. It's the new Gen C and CINES supercomputer. It's named Oxygen. It's about 2.2 petaflop power. It was at the 26th place last year in the biggest supercomputer in the world. And now it's 36th place, but it's quite a good machine. We have another mission, which is a long-term preservation of data and digital documents for university and public research institution. And then we are a data center, so we perform hosting for French national level academic institution. So, Jérôme is going to perform the presentation of data center.
Hi. Firstly, I will answer the question why we use a data-centric architecture. In fact, HPC have their own fast storage, but which is not secured. It's meant for performance. We also need to share data between different environments. And as HPC lives, they also die, and the data must remain. So we have to keep them in a data-centric architecture. That's why I will present how our architecture grown from a first NFS server to a Lustre-HSM1. And then we will focus on the different machines and processes involved in this architecture. So here is a data view of the CINES. You can see the main HPC here, which accesses the data using a Lustre-HSM. We have also other clusters that accesses data through an NFS protocol. And we have also long-term archiving solutions. And all of this data arrives on our architecture with a Lustre part and also tape libraries for high volume. So it started in 2008 with a monolithic file server here, which was based on disks, XFS disks, and for the not often accessed data, tape libraries here, 2 copies. Users copy data from the HPC using a service node to the file server using a 1 gigabyte NFS connection. You can see that compute nodes were not able to access this data. This relies on a manual copy from the user. This was made of half a petabyte of disk accessed through NFS with a 1 gigabyte bandwidth, and there were close to 2 petabytes of tapes The offered service were unlimited storage thanks to the DMF-HSM tool. And we were able to backup and restore data with a 50 days retention period. This was mainly based on the XFS dump abilities. And the tool we used were DMF and XFS. Next, we made the structure evolve, adding a Lustre file system connected to the HPC using 3 gateways. And this gave us 5 gigabytes bandwidth. So this time, all the nodes, compute nodes and service nodes were able to access this storage. And we also improved the DMF part because we spreaded the functions between many servers. One of them was responsible for copying data. And it works like this. User writes to the Lustre part, and then we add a scheduled copy responsible for copying data from this Lustre file system to the DMF part. So firstly on the disk, and then DMF was responsible for copying them to the tape libraries. So for doing this, we added a Lustre file system with a bigger bandwidth. We also added virtual tape libraries, which are very useful for small files. And this architecture offered faster and secured storage, and also storage for which compute nodes were able to access. And the tools we used were rsync to copy from Lustre to our CXFS space. And we upgraded to a parallel DMF architecture using a CXFS file system. In fact, we expected with the architecture to add a Lustre-HSM feature, but in fact it was not released yet, so we had to manually copy data using rsync. Currently, we upgraded the architecture using a bigger Lustre file system with a bigger bandwidth. So we had to add more gateways, of course. And we also provided high availability PDMF architecture, doubling every component here. So now it works like this. On the HPC, users copy data or their job ends data on a Lustre file system. And then Robinhood is responsible for copying data from this HSM, Lustre-HSM file system to the XFS part, and then to copy back on tapes also. In fact, big files directly goes from the Lustre-HSM to the tape libraries, and small files goes first to this part and then on tapes. So we have an upgraded Lustre solution with a fast bandwidth and with HSM feature. We also have an high availability cluster. Now we offered faster storage, a nearly unlimited volume thanks to the HSM feature. And we have an automated secure process based on Robinhood, but we do not have anymore an easy restore process to restore data if the user deletes it, for example. So it's a job to be done. So here is the same architecture with some more details. So you can see the PDMF part, and on this side the Lustre part. Now I will talk a little bit of the machines involved in this process. Of course, we have a Lustre cluster, a DMF cluster, and a Robinhood machine. The Lustre-HSM cluster is built on 2 DDN disk storage. They are based on SAS disks. We use the 2 MDSs, 12 OSSs, and 12 LNet gateways. All of these are connected through an InfiniBand over-the-air fabric, and we run the 2.5 Lustre distribution. The parallel DMF part is based on the 2 CXFS and DMF clusters that acts in an high availability cluster. We have 3 DMF data movers responsible for moving data, 2 NFS servers to export data for other environments, and we use the NetApp disk controllers with 2 terabyte SAS disks. The Robin Hood machine is a classical machine with enough memory. We use SSD for the database part because it's very useful to have good performances for the database. And at last, to have 2 copies of the data, we have 2 tape libraries. The first one is made of IBM drives, which are really faster. And the second one is based on LTO4 drives, which are a bit slower, but which allow us to have 2 copies of the data. The biggest interest for these machines is that it gives us a low terabyte cost, and it also allows us to extend easily the volume. Currently, we are getting 10 petabyte extension to store more and more data. Another part which is interesting is the virtual tape libraries. It allows us to store small files because 90% of the files in number are small ones. And so this massive array of idle disk is perfect to give random access to data compared to tapes, of course. The only problem is discontinued product, so we hope there are other products that exist that answer our needs.
So with all this setup, what can we do? In fact, we can do some very basic things, but it's very important for us because we can securing data, we can gaining space on our main Lustre file system, and then in a more difficult way, we can restoring erased files. First, I have to say that all this is done by Robin Hood, but for this documentation and to follow the whole process, we are going to do it manually. Okay. So if we want to secure file 1G, first we can check its HSM states, and we can see that there is nothing because the file is in regular state. It's only on the Lustre file system. To secure it, we just have to run the HSM archive command, and then if we check again the HSM state, we see that nothing seems to change. So it's because this process is an asynchronous process. So we have some information that we can follow the whole process on the other part. So if you look on the MDS, where there are the coordinator, there is a special prog file which reports all the active requests, and we can find some clue about our request. So we have an FID. With FID2 file, we can see that it's our file 1G file, and then an action, archive. So at this point, it seems okay. But on this part, we see that the action is waiting for the copy tool to perform the copy. So if we go to the GMF copy tool site, which is in the verbose mode, because So we can see that the DMF copy tool is performing the task. So it's copying our file to a special place in the archive that Jérôme presented you. And then at the end, the action complete, they work. So the thing is okay. If we go back to our Lustre client and we check the HSM state, this time we can see that the file exists and is archived on the archive AG1, but at least we have only one archive AG. So now, if we try to gain some space, there is a LFH HSM release, and this time, if we take a look, we saw that that the action made instantly because it's a synchronous process. Oh, okay. So these tools-based these tasks are very easy to perform. It's very important for us. So if you want to use Lustre-HSM, don't be afraid. It's a good stuff. But if your user delete the file, what can we do? But we have a special directory, which is the archive shadow. In fact, it's not anymore, sadly. So since the last version of our copy tool, we have no more shadow directory. Though we cannot simply copy the shadow file to our Lustre directory. So how can I restore file? Thanks to Robinhood and this soft deleted process, when a file is deleted, Robinhood saves the FID and pass into a soft event table. So that's the scheme of the table. And then with a very simple SQL request, we can find the FID and the full path of our file. So we got the FID, which can deduce the good path. Oh. And then we just have to copy the file from the archive to the Lustre file system. Okay, so it's worked fine, but obviously it will be tricky. So if we got a lot of files, we have to make some script, and we wish that it should be a more integrated process.
Okay. To conclude, now we have HSM functionality that works fine, and it's good for us because we waited for it since a lot of time. We had 6 months late because of bugs in Lustre and so on. So it's in production since March this year. We don't have a support for the Intel IML supported by the integrator. So we have an Intel installation, but we don't have the cool scripts and so on to start, stop, and to have some GUI view of our cluster. And we do not have an easy restore functionality. We were used to use easy tools to restore data, and now it's a bit tricky if we want to restore, for example, a full tree of data. We expect, of course, to have an easy and efficient restore functionality, and also we are looking for more tools able to deal with tape libraries. For the future, we don't know how Lustre and Robinhood version will evolve and will meet our requirements. We would like also to have better copy tool integration, able to migrate data. And we don't know also how the system will behave when the disk will be full, since now it's not full. We are putting data in it, but we want to know how it works with the HSM to free data. Thank you. Do you have any questions?
The question is, what is the Narcis? Is a system that you build
Ah, okay. Narcissus is the name of firstly the machine, which was monolithic at the beginning, and it's a kind of a project. It's the file server. It's the DMF part of the data-centric architecture. It's a name of
the function is a data mover from tape and disk.
Yes, the function of this is to move data from Lustre here to the archive for the inodes, and then to have a copy on tapes.
The archive is a file system, always a file system, or always a Lustre file system, a different file system.
It's a CXFS file system, yes. It's mainly used to store the inodes of the files, and the data part are on tape.
And when you speak about the disk is full, you refer to the Lustre-HSM.
Yes. Currently, we have 1 petabyte of data stored on the Lustre-HSM, and all of these data are also copied to the archive or on the virtual tape library on the tape library.
When you move the data from Lustre-HSM to tape,
Yes.
in the Lustre disk, the data, the file, restore also all the data in the disk, or is only a pointer to the real data stored in the tape?
In normal configuration, data are copied on this part of the architecture.
You have two copies,
Yes.
one on Lustre and one on tape.
That's it. And if we get more and more data here, older data will be freed from this part.
Okay, so your expectation is that the old data are freed?
Yes, we hope it will work as designed, and when the disk will be full, it will free correctly and the space in order to add more and more files in it.
But now you can check this functionality to change the threshold to free the space.
Yes, but we are in production, so we don't want to try it yet. Okay. we have 10 million files on the file system.
Thanks.
Hi. Can you tell me a bit about your file size distribution? I mean, I was really intrigued. You were talking about, separating the large files from the small files. We got a lot of bio guys onto our cluster, and so we're drowning in small files, which has made it difficult for Robinhood to keep up, even though we have SSDs.
So at least we try to keep a low level of files. So we have 10 million of files. It's quite huge, okay? But at this time, we'll be good with our actual configuration. Work very well. We have no issue with our MySQL database. So we are quite happy. And for the migration purpose, most of our files, maybe 80%, are under 1 megabyte. So most of our data are small. So we got a lot of data on our archive and VTL. Okay, and so at this time it works quite well in this way.
Okay, thanks. Yeah, we're over 1 million items right now, so.
That's okay.
All right, thank you.
Hi. What sort of latency do users see if they're trying to access files from the archive?
From now, files are both on the Lustre and the archive, so no latency. Zero latency.
Previously, when users works only using an NFS export of the CXFS part, they were they know that there were some latency accessing data when data was old and was on tape. So in this case, they call us and they ask us to retrieve data from tapes for example, the next week, so they be able to work directly on disk.
Can the users, in the future when you have data only in the archive, will the users be able to run the LFS-HSM restore on
On one hand, it's interesting for the user to be able to do it by himself, but in fact it can be problematic because we have 10 drives, and so if every user do this can lead to some kind of deadlocks. So we prefer telling users to call us and we do the job for them.
Maybe you just talked about that. When you said restore, you're not talking about undelete. You're talking about, or are you talking about undelete?
Yes, we talk about undelete functionality because users sometimes made mistakes and they want to get the data back. So that's it.
Yes, about undelete, what should be done is to make Robin create a new file, a new feed, and then there is no way currently for Robin to tell to the copy tool to change the feed in the backend. Because when you want to undelete, you create a new feed and you want your archive file to be associated to this new feed. So there is something to be done at different levels in Robinhood, in Lustre, and also in your TMF copy tool to implement this.
Yes, we know. So we started because some users did mistakes some weeks ago. So we had to restore files. And so we started to write scripts, but it's homemade scripts. So we are not very confident as we be confident with some integrator scripts or